explaining the regression analysis, explain number 5. So here it is to perform a regression analysis on a market data set using a Python and Pandas and predict the sales using a simple linear and multiple linear polynomial lasso risk regression. The performance of each regression model is evaluated using R score and root mean square error. And so we have like 10 questions. So first one is like input the data set. First I input the required libraries. Pandas is used to read and manipulate the data set, and NumPy is used for numerical calculations, and it is used to divide the data set into a training and testing data. Linear regression, lasso and ridge used for regression models. Polynomial feature is used for a polynomial regression. R2 score and mean squared error are used to evaluate the models. Next, pd.read csv market.csv reads the market dataset and stores it in the variable df. When I write df, the complete dataset is displayed as the output. So, next one is like display the first 10 rows of the dataset. df.head. So here you can see this output. Here I use the head functions to display the first 10 rows of the dataset. The output shows the first 10 records along with their column values. This helps us to understand the structure and the type of the data present in the dataset. Next one is like last 8 rows. df.tail of 8. Here I use the tail of 8 function. It displays the last 8 rows of the dataset. The output shows the final 8 records of the market dataset. The fourth one is like display the information about the dataset. First one is info. Provides the overall information about the dataset. The output shows the number of entries, column names, null values, and data types. This is useful for checking whether there are missing values and understanding the structure of a dataset. Next one is column names, where df.columns display all the column names in the dataset. These columns represent the variables available for our regression analysis. df.shape gives the number of rows and columns. The first values represents the number of rows and the second values represent the number of columns. So the output tells us the size of our dataset. Then the statistical inference. It is like describe. Describe provides the statistical information about the numerical columns. It gives values such as count, mean, standard deviation, minimum, maximum, and quartiles. This helps us to understand the distribution of the data. Next one is data type. df.dtype. df.dtype displays the data type of every column. It helps us to identify whether each variable is numerical or categorical. Then fifth one, perform the following regression. Measure the performance using R2 score and root mean squared error. First one is simple linear regression. So now I perform the simple linear regression. First I assign YouTube as an independent variable x and sales as a department variable y. Next, train test split divides the data into a training and testing sets. I use set size is equal to 0.2, which means 20% of the data is used for testing and 80% for training. Random state is equal to 42. Ensures that the same split into updated every time the code is executed. Next, I create a linear regression model using a linear regression. The fit function trains the model using the trained data. Then a predict function predicts sales values for the test data. Finally, I calculate the two performance measures, R score and RMSE, where the output shows here. In the output, the R score tells us how well the model explains the variation in sales. A higher value indicates better performance. RMSE tells us the average magnitude of a prediction error. A lower value indicates a better performance. A value displayed here are the performance of a simple linear regression model. Next one is multiple linear regression. So here we written like multiple model fit of X train and Y train. But X train will still contains only YouTube. That means your multiple linear regression is not actually multiple regression. Now I perform a multiple linear regression. Unlike simple linear regression, here I use 3 independent variables, YouTube, Facebook, and newspaper. The dependent variable is sales. Again, I divided the data into a training and testing sets. The model is trained using a fit and predictions are updated using a predict. Finally, R score and RMSEs are calculated. So here the output shows like RMSE and R square of the multiple linear regression. I compare these values with the simple linear regression results to determine which model performs better. Next one is polynomial regression. So here, next I performed polynomial features of degree 2 converts the input variables into polynomial features of degree 2. So transform is applied to the training data while transform is applied to the testing data. Then I create a linear regression model using the transformed polynomial features. The model is trained and used to predict the test values. Finally, R square score and RMSEs are calculated. So the output shows the R square score and RMSE of the polynomial regression. Again, the higher R square and the lower RMSE indicate a better performance. Then lasso regression. I perform the lasso regression is a regulated regression technique. Here alpha is equal to 1 controls the strength of the regulations. The fit function trains the lasso model and predicts the generated predictions for the test data. Finally, I calculated R square score on RMSE. The output displays the R square score and RMSE for the lasso regression. These values will later be compared with the other regression. Next one is risk regression. Finally, perform the risk regression. Is also a regulated regression technique. Here, the regulation parameter alpha is set to 1. The model is trained using a fit and predictions are generated using a predict. R square score and RMSE are then calculated. The output displays the R square score and RMSE for the risk regression. These values are used in a final comparison. So here the output shows. And next one is the comparative table. Now I create a comparative table using a pandas data frame. The table contains the 3 columns. The first column contains the regression technique. The second column contains the R square score. The third column contains the RMSE. The output gives us a clear comparison of all 5 regression techniques. For R square score, the higher is better. For RMSE, the lower is better. So here the output shows like simple, multiple, polynomial, and rich. And the final one is like interpretation. Finally, I identify the best performing models. IDX max finds the row with the highest R square score. IDX min finds the row with the lowest RMSE. Therefore, best R2 stores the model with the highest R square score and the best RMSE stores the model with a lower RMSE. The output tells us which regression techniques perform the best according to each evaluation metric. According to my output, it shows the highest R square score. Therefore, these are the best performing models according to the respective evaluation metrics. Thank you.